Okay, so this question here is asking us to get the mean, median, and modal age of this data set here. So first thing we're going to talk about is mean. Mean is just the same thing as average. So what we're going to do to get the mean, you just add up all these numbers and you divide them by the amount of numbers there. So we're going to do 24 plus 24 plus 26 plus 27 plus 30 plus 33 plus 33 plus 33 plus 39. All of that divided by the number of numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to give you the mean. So when you calculate that, you should get that the mean age is equal to 29.89. That's the mean age. The median, remember, median, middle number. So in this data set, we have 9 numbers. So the middle number is going to be the 5th number. So 1, 2, 3, 4, 5. This one here, this is going to be the middle number. That's our median. So the median is equal to 30. And then the modal age. Mode, most common. They both have a mo kind of starting at the start of the word. Modal age, most common. So we have 24 twice, 26 once, 27 once, 30 once, 33 three times, and 39. So 33 is going to be the modal age here. So our mode is going to be 33. Boom, done. This question here, we have scores on an entrance exam to a top college were distributed with a mean mark of 160. So mu is equal to 160 immediately. And a standard deviation of 25. So sigma is going to be 25. Immediately, before we even read the question, write those down. Then, work out the grade needed to be considered if the college only considers the top 15% of scores. So basically, what I would always do here, before I even start the question, draw the distribution. So, to be able to use the log tables, we're going to have to convert this into a z-score. So the formula we use there is z is equal to x minus the mean over the standard deviation. So they're only considering the top 15% of scores. So if we draw that, let me get a red pen. If we draw our normal distribution here, it looks something like this. Goes up like that and down like that. That's a poor sketch, but you get the gist. And they only considered the top 15% of people, yeah? So here, we're going to say this blue shaded region is 15%. That means, I'll color it in green, all this down here is going to be the remainder, so it's going to be 85%. Now remember, the log tables read area from left to right. So the value, we actually want to get z in this example. This is the z value here. Because the area reads to the left, we want to get the z value that will give us 85% or 0.85% of the... We want to find the z value here that will give us 85% of the area to the left of the graph. We go to our log tables. We look for 0. I'll draw them black actually. We'll go, the area is going to be 0.8500 or something as close to that as possible. Looking at the log tables here, I have that a z-score of 1.04. Yeah, 1.04 gives me 0.8508, which is close enough. So that means our z-score we found is 1.04. Now, the question asks, what grade do they need to be considered? So we're going to have 1.04 is equal to x minus the mean. The mean is 160 divided by the standard deviation, which was 25. So that means that the grade needed is equal to 1.04 times 25 plus 160. We just rearranged that there. So 1.04 times 25 plus 160. That means their grade has to be 186. That's the grade they need to be considered for the college. Just the key here is, remember, the log tables read area to the left. So in this case, we wanted the grade. We needed to get the z value. And we knew that 85% of the area was down here to the left. So all we need to do is look at the log tables, find 0.85 or as close to that as possible, get the Z value, and then get the score. X was equal to 186 was the answer to the first part. Now, the next part of this question is saying what proportion of the students scored between 150 and 175 marks. Again, first thing I'm doing here all the time, I'm drawing the distribution. So it's going to look something like this. It's just for yourself, just to be able to visualize it. So the mean will lie there. And now it's saying what proportion of people got between 150 and 175. So notice the mean was 160. So 150 is slightly below the mean and 175 is slightly above the mean. And the mean is going to be this center line here. So it's like, we'll say like 150 is somewhere here and we'll say like 175 is somewhere here. That means that we're going to want to find this area here in between. And remember, the tables in the log are the tables. The log tables give you the area to the left. So say if I was to convert this X value into a Z score, then I would get the whole area down to the left here. But I only want the area down to the 150. So what I could do, I'm going to draw two more distributions. Okay, so I've just drawn it again here. So if I was to get this X value, 175, if I was to convert that to a Z score and then get the value from the tables, I would get the area all the way down to the end here. But again, I only want the area down to this 150. But since the distribution is symmetrical, I can actually flip this and I can put the 150 here. And then if I was to get the area to the left of the 150, the remaining area would actually be, I'll color it in yellow here. This area here would actually just be this guy here. So what I'm going to have to do is I'm going to first have to get the area of the 175 down to the left, but then I'm going to have to minus off this yellow area. And to get that yellow area, I have to get the 150 to the left, but I know this area here, the total area under the curve is 1. So this area here is going to be 1 minus this green area. So that's what I'm going to do. Continue here. So again, Z is equal to X minus the mean over the standard deviation. So firstly, if I put in 175, Z is equal to 175 minus 160 divided by, what was the standard deviation? 25, yeah. Over 25. And then you just plug that into your calculator. That's 0.6. And then I'll call that Z1. Z2 is going to be 150 minus 160 divided by 25. And that's going to be minus 0.4. Okay, so firstly, I'm going to get the area that this Z1 will give me. So that corresponds to this 175 here. So a Z score of 0.6 is going to give me 0.7257 in the log tables. Okay, I'm going to color it in green, or I'll try it my best to. There we go. There. That guy here, that's this area here. Now, actually, I should have colored this guy in. I'm going to make this guy blue now, just for visualization. That's blue. Now, Z2, we can't get the area from a negative Z value. That's why we have to flip the graph. Now, Z2 we have was minus 0.4. We can't get the area from a negative Z value. So you're going to have to flip the distribution. So if I say this is 0.4, that'll give me, if I look at my tables, that'll give me 0.6554. Now, what area does this correspond to? This is going to be the blue area here. Okay? Remember, we have to flip the distribution because it's symmetric. And that's going to give me the blue area. I don't want the blue area. I want the yellow area. So remember, to get the yellow area, it's going to be 1 minus the blue area. So 1 minus 0.6554. So that's going to be what? 0.3446, I think. Perfect. So now that's the yellow area. This guy here. That's the yellow area. So our final answer, remember, go back up to the top. Our final answer was the green area minus the yellow area. So that means the answer is going to be, the green area was 0.77257 minus the yellow area, 0.3446. Boom. So the answer is going to be 0.3811 or 38.11%. That means that 38.11% of people scored between 150 and 175 marks. The most difficult concept here is the fact that we have to minus off this yellow area, and then you have to flip the distribution. It just makes it a lot easier if you just draw it out. If you draw it out, and remember, the area goes from right to left, and you can't get a negative z-scores area, so you have to flip the distribution. So, the last question here. In 2022, young adults in Ireland had an average screen time of 5 hours. A study was conducted in 2025 to see whether this had changed. After asking 450 people, the mean screen time was 3.5 hours and a standard deviation of 1.25 hours. Carry out a hypothesis test at the 5% level of significance to see if the average screen time of the young adults has changed in Ireland. So, hypothesis testing. Always. First thing you do, H0. So, the last question here, we have in 2022, young adults in Ireland had an average screen time of 5 hours. Then, a study was conducted in 2025 to see whether this had changed. After asking 450 people, the mean screen time was 3.5 hours with a standard deviation of 1.25 hours. Carry out a hypothesis test at the 5% level of significance to see if the average screen time of the young adults has changed. So, immediately, hypothesis test. Don't even think about it. H0 and H1. The null hypothesis and the alternative hypothesis. The null hypothesis is going to be that the mean screen time hasn't changed. And then H0 is going to be the opposite of that. Mean screen time has changed. Boom. So, what are we going to do here? This is a population mean hypothesis test. So, our confidence interval is going to be x bar plus or minus 1.96. That's because it's a 5% test times the standard deviation over the square root of n. X bar here is going to represent the original average or the original mean, which was 5 hours. So this is going to be 5 plus or minus 1.96 times the standard deviation we found to be 1.25. 1.25 over the square root of n. Number of people, 450 people. So over the square root of 450. So let's calculate that. When we calculate that, we're going to get that our proportion is 5 plus or minus 0.115. So the interval is going to be 4.88 hours and 5.12 hours. But the mean we got, if we go look back up here, it was 3.5 hours. The mean was 3.5 hours. That is not in our interval. Our interval is between 4.88 and 5.12. The mean of 3.5 hours is not in this interval. So we fail to reject HO. The average amount has changed. See HO, the mean screen time hasn't changed, so we reject HO. Sorry, did I say we fail to reject? We reject H0. The mean screen time has changed. That's the most tricky part, is thinking, do we reject or do we fail to reject? See, the H0 here was the mean screen time hasn't changed, but we deduce that it has because this isn't in our interval. So we reject H0 and the mean screen time has changed.